This is the final project for the course. We're going to put together all of the basic parts that we learned about. Debugging, variables, printing, Arduino functions, loops, input, if statements, arrays, maybe cell arrays, and definitely plotting to be able to complete this exercise. A good place to start is to create pseudocode, as we mentioned in the beginning. So at a high level, no programming in there, but just at a high level what you want our program to do. And then next start filling in parts of the code and test as you go. So the final test that you'll have is for 10 minutes. You'll run it for 10 minutes and observe how well it does at tracking the temperature. Maybe you could use a shorter time, like 10 seconds, as you test your code. So let's go ahead and jump right into the objective. There aren't a lot of details here, kind of on purpose, so that you can define them. And I'll walk through this, but really it should be your program and your ideas that you bring. Now some students are going to make a nice graphical user interface, and others are going to be very simple and succinct. So wherever you are in between, that's okay. The main thing is that you're exercising some of the skills that you learned, and don't be afraid to go back and redo an exercise if you forgot how to do it or it didn't quite sink in all the way. Okay, the objective is to program the temperature control lab to maintain a temperature at 37 degrees by adjusting heater 1 or Q1. We want to display the heater level with an LED indicator as the program is adjusting the temperature. We'll also create a plot of the temperature and heater values over a 10-minute evaluation period. Alright, so let's go ahead and just start with some pseudocode. What we want to do is maybe at the very first just input the target temperature. Alright, and ask the user for it, maybe validate the input. Make sure the user didn't put something in that's unrealistic. Okay, as a next step, we want to then set up a loop. And inside that loop, we're going to do a few things. One is read the temperature. Alright, and then we'll make a decision. Okay, on decision on the level of the heater value, and then we'll also adjust the LED. And then after we're done, we're going to also create a plot. So we'll visualize the data to see how well we did over that time window. Okay, so let's go ahead and just get started. I haven't necessarily even created a solution for this, so I'm kind of going through, and you'll see the process that I go through of working things out, debugging, struggling with it as we go. Okay, so first of all, I want to just clear all. All right, now that is so that we don't have any variables left over. For example, a connection to the TCLab. All right, and then the next thing is I need to get an input. The target, we'll have that come from the user. And that will be what is the target temperature. All right, and then we want to validate it. So maybe if target is greater than 40, we'll print out a message like, please confirm this high temperature. Okay, and then else if target is less than 25, we could say please confirm this low temperature. All right, and and that would be at least a warning to them, so that if they need to stop the program, they can do it. Okay, and else, we would have an else, but we don't need it there, so it's just going to continue on. It's not going to have any of the conditions if it's between 25 and 40. All right, so maybe we could print out something like target temperature equals, and then we could just print it out just to show them what they just input. Okay, and let's see if I've got the number of parentheses right. There we go. All right, so here we have the target. And so we input the target temperature and we validated the input. Now the next thing we need to do, and I guess I should have said connect to TCLab. That might be the next thing that we need to do. So let's go ahead and do that. Lab equals TCLab. And then now at this point, we want to have our loop that's going to start. So I'll say for I equals 1, 2, and then it would normally be 600. That's how many cycles it's going to go for. But let's just go ahead and reduce it down to just 10 seconds. Okay, just for testing for now. And then I can just remind myself that I need to put back in 600 for the final test. Okay, I'll put an end there. All right, so now what we want to do is we want to read the temperature. So the temperature is going to be lab.t1. So we can do that just once and store it, just so we don't have to continually read it over and over again. All right, now we'll make a decision about Q1. So let's do an if statement. So if T1 is less than target, then we could do something like lab.Q1 equals, let's say 100. Okay, we're going to turn it on full, and I'll just go ahead and put that in as 100. All right, and then else if T1 is greater than or equal to target, or I can just do else there, then lab Q1 is 0. So if it's too low, it's going to turn the heater on all the way, and if it's too cold, away. All right, there's my Q1. And now what I want to do is adjust the LED. So I want to adjust that, but I'm using this 100 or 0 in, let's see what I need to do on the LED again. Okay, with an LED indicator as the program is adjusting the temperature. So the LED could be an indicator maybe of the temperature or of the heater value. So let's go ahead and make it an indicator of the temperature. All right, so here I'll just say lab.led, and then I'll put in T1. So it's going to be equal to the percent, but let's make it just a little bit more sensitive, so it's almost like it turns off at room temperature and then gets brighter as it goes. So I'm going to put that at minus 25. So if it's equal to 25 or 23, depending on what room temperature is, I may need to just clip it at 0. So if I do max 0 comma that, then it's going to be the lowest it can get is 0. Okay, so I can't put in negative values if T1 is below 23. All right, so there it is. There's my basic program, and then I need to go ahead and clear lab to close it. So let's just run this one first. Okay, there's 37. Target temperature is 37. All right, and I'll just put as I go through it, I don't want to print that out again. So there I have my, okay, some values. Let's go ahead and just check on those. Okay, what they are, I had LED, I put that in, you can see those 2.75 above. Okay, so that one's working. You can see a very dim LED there, and you can see what the heater value went to. Okay, so that looks like that's working. The heater turned on to 100%, and then it you know, was done and turned off. Okay, I'm going to put in a lab off here as well, just to turn off the heaters when it's done. Okay, test that one more time. There's the target temperature. I should probably put something in, you know, above 40 so that you know, it'll check it. Okay, so there's it turned heaters and LED off. Perfect. Okay, so I know all of this is working now. Now I want to be able to store the data so that I can visualize it at the very end. All right, so let's see. What I'll need to do here is now, instead of just T1, what I'll do is T1I. And so I'll make that an array. And anywhere else I see T1, I'll just put in the I. So it starts storing it, and it'll have 10 different values as it goes. And then the other thing that I want to do is maybe do the same thing with Q. Okay, so Qi equals 100. And I'm going to take this out and then put in Q1I. Okay, and the same thing here. And I'll just make that Q1I equals 0. Okay, so it's going to be storing it locally on this Q1. And then I'm just putting it in, whatever Q1I is, I'm going to put it in right here. Okay, let's put in a little bit of a pause now. Okay, so we want to hold it for a second, and then it will continue on. All right, and one way to time it is to do, so just a little bit more advanced, because all of this takes just a little bit of time. I can do a tick and then a talk. Okay, T equals talk. Okay, so it's like tick-tock for a clock. And so you start the timer here and then end the timer. And so let's just go ahead and display T now. All right, just to see how long it takes to do everything else besides the pause. Because it'll take just a little bit of time to make those decisions, to write the value out to the Arduino. Okay, so it took, you know, about 0.07, 0.05. So we don't want to necessarily pause for 1 second. We want to pause for 1 minus the amount of time that it took us to run all the rest of that, so that it equals, so we'll equal 1 second exactly, instead of you know, 1 second plus 0.07 or 0.05, which can add up. We're not going to be exactly 1 second each cycle. Okay, so I'm going to pause for just a little bit less than 1 second. I may need to put a max on there as 0, just so it doesn't try to pause for negative number in case one of the cycles takes a long time. I don't think it will, but just in case it does. Okay, so that just protects that input so it doesn't ever go below 0. Maybe we also need just a little bit of a pause there in case it's, you know, CPU is maxed out for whatever reason. All right, now let's go on to the next one. We've generated the data, and then let's generate a plot. And for this one, I'm going to go ahead and comment out the T, and let me get rid of a couple spaces here. I should probably put in some more comments as well. Okay, so good practice is to put in a couple comments. Now, if you put in a double in Matlab, it'll make a new section break, which is nice. It helps you organize them just a little bit better. And I'll just do that here. So this is going to be connect to TCLab. And this will be validate the input. Okay, so I'm just following the pseudocode here. And then I will loop for 10 minutes. All right, and I'll change that back to 600 for the final test. So I think we've got everything here, but let's just go ahead and check it with a plot. I'm going to run this one more time. I'll say 37 degrees, and then I'm going to input just another cell below, okay, just for the plotting. And this will be to visualize the data. So it's still running up above, but I'm going to work on this while it's finishing. Let's go ahead and just print out T1 and just look at that. Okay, so there are the temperature values, and let's print out Q1 as well. Okay, and those are the heater values. So the thing that we need to do is we want to plot time and Q1, and then we also want to plot a time and T1. But we don't have time yet. That's one thing that we forgot from up above. So one of the ways you can add that is those are going to be 1 second each. So you could do linspace, linearly spaced values between 1 and 10. And then we're going to have, let's see, 10 values, okay? All right, so let's go ahead and just plot those. I didn't include the hold on. I need to do that if I want to see both of them. All right, so there you can see the temperature, and then the heater value is just going to be 100, so it's right here at the top. A little bit hard to see. All right, but these are on different scales, so we probably want to make some subplots here. So I'm going to make a subplot with the very first one is going to be the heater value. And then I can just get rid of the hold on because I'm going to have a separate subplot. All right, and I'm going to put this into the second one. So let's just go ahead and plot this. Now you can see the scale is a little bit better. You can see the temperature here as well as the heater value. All right, so let's go ahead and keep going with this. This is, it looks like we've got the data. Maybe what we do is we just initialize it. So we get a time 0 as well. Or we store the time. All right, so let's go ahead and store time and the data. All right, and let's make this T1. All right, I'm going to make that just be equal to a blank array, or I could put in the current value right here. So that's just at time 0. All right, and then what we want to do is say Q1 equals 0. Maybe it's starting off at 0, and then time equals 0 as well, just to give us a good starting time. And then I just want to append to this. So end plus 1. I'm going to add on to that. All right, and then we have end plus 1, okay, for our T1, and then end plus 1 for Q1, and end plus 1. I'll just replace these. Ooh, you know what? I augmented it here. So now it's just going to be the end value right here. Okay, and then right here as well, I've already made it one larger here, so this one just needs to be end. All right, let's keep going. T1, the end value. All right, and let's just do this, or I'm going to say that time end plus 1 equals I. All right, now let's test that for 10 seconds. Okay, so what I was doing there is just, I want to store these. I want time, I want T1, and I want Q1. And I'm just going to start this out by saying that's 0. That's going to be the current, lab.T1. And then this one is going to be equal to 0. And then this is probably going to turn on to 100 and then be 100 for a few cycles. I'm going to continue to read this each time after a second, and then this will be 1, 2, 3 on up. So every time I go through the loop, I'm just adding some new values right there to my array, and then I want to plot those. So this is going to be my X value on my plot, and then these are going to be my Y and my Z value. Okay, so I want an array so I can store those and then plot them later. Let's see if that also turned out. Oh, the vector lengths must match. Oh, there it is. I think I needed Q end plus 1. Okay, that one is okay. Let's see where I made a mistake here. Okay, they're different length of vectors. One of the, oh, I had time here. I shouldn't have redefined TM there. Okay, so I need to run it again because now they're different and it'll run. I could even put the pause, less than, I can make it even smaller if I wanted to. All right, I'll wait for that to turn into a number. That means it's done. And then I can visualize the data. Okay, so it starts with 0, goes up to 100, and then stays at 100. And there you can see the temperatures. All right, let's go ahead and keep adding to this. But while we're doing that, let's go ahead and set this to the 10-minute. Okay, so it can start, and then we can see how well it does. And I'll put 10 for testing. Okay, just a comment there. All right, and let me put just a few more comments in here. Okay, read the temperature. And this one is going to be adjust the heater. All right, and this will be indicate temperature with LED. I can make it blink or something like that. When it gets to the target temperature, maybe it is solid. All right, and then this will be record the time. And this one is make sure there is a 1 second exact pause. All right, so there we have it. I'm going to run this for the 600 cycles now. It's just going to be going, and then what we'll do is work on these plots down here just while that's going. Okay, so the plots, we want to start adding to it. We have the data there, but this is, we want to add some more things there. One of the things we can add is, what is the target temperature, so we can see that on the plot. So one way to do that is just hold on to this second plot, and then we'll add, let's see, this one's going to be time. Let's just go ahead and do time 0 and then time end. So we just want 2 points. And then we want to plot the target and target. So just 2 points, time 0, time end, target, target. So it's going to be just a horizontal line where the target is. And let's make that a black dotted line. Okay, and right here we want to have this be maybe a red solid line. All right, the heater value, I'm going to make that a blue dashed line. Okay, and because this, let's go ahead and put some dots there on the red so we can see where the actual temperature readings are as well. And let's start adding some additional things like, Y label. This one is going to be heater. And we can also add a legend. And so the legend, we could say that's Q1. I'll add those same things to the second subplot down below. But instead of heater, this is going to be temperature, and that's going to be T1 and then the target value. Okay, so I'm starting to just fill this in with more. We also probably want an X label. Okay, and this one, it's going to be time in seconds. But we're going to be going for 600. Maybe it'd be easier to see this in minutes instead. So the way we can do that is just divide by 60 for the end time, and or up here at the very top, we'll adjust TM to minutes. All right, so TM minutes, I'll do TMM equals TM divided by 60. And then we can use TMM here instead of TM that's in seconds. Okay, so just making a couple adjustments. Also, you can see that the 100 really doesn't show. It's going to be 0 or 100, and it's kind of off the scale. So let's go ahead and just set some Y limits as well. I maybe want to go from -5 to 105 just so we can see the plots. It doesn't interfere with the boundaries of the plot. Okay, well I think that looks pretty good right there. We could add additional things. We could but I think for right now this is probably just a good plot to start with. We could also save it dpng, and then I'll save it as this is going to be incubator.png. Alright, so just saving the file. And if you're in Matlab, you can also do save as, and then you can just do incubator.png. Okay, or the print works as well for Matlab. Okay, we have it. We've generated the plots, and it looks like everything's in place. If again, you can modify this how you want. The other thing that we'll want to be looking at is maybe this isn't the best way to control the temperature, all the way on or all the way off. And so there's, think about other ways that you'd improve that. I'm just going to show this for today, but there are many other ways to improve that. You could use something like a PID control, or you could use something even more advanced like a model predictive controller. Those are covered in other courses. I don't really want to get into the details here of those, but just realize this type of controller is kind of like the controller you would have in your home that is like a heating or air conditioning system. It's even more basic than that. So let me just give you a challenge with this. In your home, when you have a heating system, you might have a target, okay, of a certain value. You set your thermostat at a certain value, but then it's going to have a high upper, an upper limit and a lower limit. So let's say you set your thermostat at maybe 70 degrees Fahrenheit, and I'm trying to think what that would be in Celsius, maybe right around 23 Celsius. So maybe you have an upper limit of 24 degrees Celsius and a lower of 22 degrees Celsius, or 68 and 72 degrees Fahrenheit. So what happens is when you're too cold, the heater turns on, but it doesn't turn off right here at that, because then you would be turning on and off the heater very rapidly. Okay, what it does is it keeps it on until you hit an upper limit, and then it turns off the heater, okay, and lets it cool down until it hits a lower limit. And then at that point, it turns back on again, and then comes back up, and then back down. Okay, so this is called a deadband. So that's something that you could use to maybe improve it, especially if you were going to wear out your heater. Okay, now in this case, we have a transistor, and it doesn't wear out. We're cycling it on and off at 490 cycles per second. That's how the pulse width modulation works on this Arduino. So we're not going to wear it out. So we don't necessarily need this band gap, but as you look at the results, you'll want to just try to figure out, are there ways to improve it? Okay, and then the other thing you could do, for example, is maybe you want to save the file. So let's go ahead and do that. We want to maybe save it in Excel just so we can look at it later. We've saved a figure, but let's also save a CSV file for viewing the data. Okay, the way that we'll need to do that is put this data together into one array. So this will be the time, and then it's going to be Q1 and then T1. So we're going to put all of those together, and then we need to transpose it. So here I'm going to do the transpose like that, and then we can save it. Save it as an ASCII file so we can read it, and then what we want to do is just give it a file name. So data.csv, and then give it our data value, the data values there. Okay, so I can also save it without the transpose. I can just save it like this. That will give me anyway, we'll look at it and see how it is. Sometimes it'll stack them. You know, it'll stack the data, you know, time like this, where it's all the numbers, Q1, all the numbers, and then T1. Okay, and what we want to do is have a matrix like that, and then we want to transpose it so it looks like time, Q1, and T1, and then we'll have the time listed here, the Q values listed here, and then the T1 values listed here. So you don't have a lot of rows, it's more in the column oriented form. Okay, let's see how this is doing. Okay, it's still going. I'm going to just pause it right. Oh, I was going to pause it. It just finished. Look at that. Okay, so let's see how we did on the plot and if there are any errors. Okay, it looks like there's the T1 and the Q1. You can see it turning on and off there. And we don't have, I think I forgot to put on the, okay, we have this other plot right here, but it's somehow not showing up. Okay, for this. So let's see if we can figure that out, why it isn't putting the line there. Because we wanted to put the 37, you know, right here, have a line that goes right across there. All right, so let's see what I can do about fixing that. Now the nice thing about this is I don't have to regenerate the data. I can just you know, plot it and plot it again, and don't have to recalculate it. Okay, so here's my subplot 2. I have legend of T1 and target. Okay, and I'm just going to break that out into look at my X value and my Y value. All right, and I'll just put in X and Y because I'm not using those. Okay, so it says that X is undefined. All right, so that might be some of the issue right here. X is not defined. Okay, so Y, we have that correctly. Let's see, subscripts must either be integers 1 to that or logicals. All right, so let's see, it didn't like the end there for some reason. So what I need to do, I think, is, okay, let's go ahead and just make this the length of TMM and see if that helps. Okay, so it still didn't like that either. Let's go ahead and print out the length of TMM. Okay, so that's 601. So for some reason, it doesn't like it that I'm, let's see. I think that's why. I forgot to do a closing, no, I have a closing bracket here, and that's divided by 60. All right, so I'm trying to get just this last value. And so I could do 0 and then 601 divided by 60, but I was trying to make it configurable so that, you know, it's going to print something like this, but it wasn't grabbing that last one. So I still need to figure that out. But there's our target temperature. You can see when it dips down below this, then it's going to turn on. Now it looks like these are not all the way synchronized up right here either. Okay, so I think the last time, even though it was 600 long, the last one was actually 600 in the time. So it just made it extend a little bit out further. But now you can see they're synchronized between the time here and the time here. All right, so I'm just going to, let's see, maybe I'll pause it and just see if I can figure that out, and then see if I have an answer for you. Okay, I think I figured it out. I was thinking index of 0, but that should have been 1 right there. That was the problem from before, and you were probably looking at it thinking, I think I know what the answer is there. All right, so there it is. I could plug those back in if I wanted to. Okay, here's my X value that I'm plotting, and then my Y value. So I can get rid of those two lines. All right. And I can get rid of the length as well, so I don't need to print that out. Okay, and let's see, it's still not plotting, so it looks like it had another problem with this. Okay, so I held on, there's 1, and then I have the length of TMM, and I'll just do the end value here. I think that was okay to do that. Okay, and it should be, it looks like that's very small right there. You can see it's, oh, I don't need to divide by 60. That's it, I'm using TMM instead of TM. Okay, so there it is. You can see the debugging. Sometimes that takes a little while. You have to take individual pieces out and look at them. And you know, print statements are good. If you have a full debugger, that's nice. You can set breakpoints and inspect variables as you go. Okay, so here it is. I have this. Let's go look at our data as well. We have a data.csv file, and what I'm going to do is just go ahead and open a new folder. Okay, and go to my desktop, and let's go ahead and begin Matlab and go into the Octave folder, and let's just look at this. Okay, and it stored it all together. So that was just one big long array. So what I can do is just transpose these. Okay, and what I'm going to do is put them together as column matrices. Transpose and transpose, and then I think that should do it. Okay, and let me go look at that again. Make sure it's in 3 columns. No, that still didn't work. So I think what I've got to do is make them separate rows like that, and then I can look at the size of it. Size of data. Okay, to make sure I have 3 rows and then 601 columns. All right, and then I want to transpose that. Okay, let's see if it was the dot. Okay, can't be indexed. I forgot what the transpose is. Let me go look at that. All right, the transpose is just that. Okay, so you're not doing a string like this. You just have the single quote at the very end. That is going to be the transpose. Okay, so I'm going to go ahead and transpose this, and then let's look at the size of the data. So it's 601 rows and 3 columns. All right, let's go look at the data. I'll reload it. All right, so there is, right there is going to be the time. Here is the heater value, and then there is the temperature. So you can bring that into something like Excel and be able to plot it, look at it with, with another program like Excel. If you do bring it into Excel and it's not comma delimited, then you need to go data and then text to columns, and it's delimited, but in this case it's going to be delimited by a space, not by a comma. And so there you have the values. Now you can just plot these. If you want to see the heater values, then you can insert a chart just like we had before. And then if you want to see the temperatures, you can do that as well. Okay, so there are the temperatures. So you can do that in Excel as well, but it's very nice to do it in Matlab or Octave because you can just generate it right there within the file. Okay, so that's it for the final project. We started with some pseudocode. As you saw, at a high level, what we were trying to accomplish with the project, and then we started to break it down into simpler tasks and just work through this to connect to the TCLab, to loop through for 10 minutes. Again, the challenge is to maybe improve the temperature control here with this. We recorded the values, and we broke it off into a separate cell for the visualization so we could run this over and over without needing to regenerate the data. And there is our final plot, and we save that away. We have our plot stored right here, incubator.png.